In this lecture, we discuss about the diazonium salt and chemical reaction of the diazonium salt. Diazonium salt, there is the process which is known as diazotization. In the diazotization, primary amine which may be aliphatic, this aliphatic and aromatic, primary amine which may be aliphatic and aromatic treated with nitrous acid in presence of NaNO2 in presence of HCl at temperature 278 Kelvin. Primary amine which may be aliphatic or aromatic treated with nitrous acid in presence of sodium nitrate in presence of HCl at a temperature of 238 Kelvin, there is the formation of diazonium salt. Then the formation of diazonium salt. This is aliphatic diazonium salt. Aliphatic diazonium salt is found to be unstable because they react with even cold water and they form alcohol. So this aliphatic diazonium salt is found to be unstable and have less importance in the chemical reaction. But this aromatic amine treated with nitrous acid in presence of sodium nitrate at a temperature of 238 Kelvin, there is the formation of diazonium salt that is known as benzene diazonium chloride. When aniline treated with nitrous acid in presence of sodium nitrate HCl at a temperature of 238 Kelvin, this aniline forms diazonium salt. This diazonium salt is stable. This stabilized by resonance because this aromatic diazonium salt is stabilized by 5 resonating structure. The aniline, when not treated with this aniline, when not treated with nitrous acid, sodium nitrate in presence of HCl at a temperature of 238 Kelvin, there is the formation of diazonium salt known as benzene diazonium chloride. This is known as benzene diazonium chloride. This benzene diazonium chloride, this aromatic diazonium salt, not react with cold water, it react with hot water. This benzene diazonium chloride, this found to be a stable compound because it stabilized by resonance, is stabilized by 5 resonating structure. This stabilized by 5 resonating structure. Say for example, this is the first resonating structure and this is the second resonating structure. This stabilized by 5 resonating structure. This one. And again, there is the formation of third resonating structure and so on. This diazonium salt is stabilized by 5 resonating structure. They are found to be stable as compared to aliphatic diazonium salt. There are some chemical reactions and so on. There are 5 resonating structures. And there are some importance of the diazonium salt in the conversion of many organic compounds. So we discussed about their chemical reaction. The process of forming diazonium salt, that is known as diazotization. The process of forming diazonium salt, that is known as diazotization. Now we discuss about their chemical reaction. In the chemical reaction, we discuss diazonium salt. Here, this group can be replaced by this group N2 positive Cl. This group can be replaced by this Cn, can be replaced by iodine, can be replaced by Cl, can be replaced by OH, can be replaced by hydrogen, can be replaced by fluorine, can be replaced by NO2. This group can be replaced by Cn, iodide, chloride, hydroxy, hydrogen, fluoride and NO2 group. This group can be replaced by. So there are 1, 2, 3, 4, 5, 6 and 7 chemical reactions. Here we discuss 7 chemical reactions. Here this diazonium salt on treated with Cu2Cl2 cuprous chloride, there the elimination of nitrogen gas and then the formation of chlorobenzene. This is an example of Sandmeyer reaction. This is an example of Sandmeyer reaction. But when diazonium salt react with copper powder, there is always formation of chlorobenzene and then the evolution of nitrogen gas. This is an example of Gattermann reaction. This is an example of Gattermann reaction, and this is example of Sandmeyer reaction. This is example of Sandmeyer reaction, which we will discuss in the chapter haloarene and haloalkane. Now, this diazonium salt, when react with hot water, even in cold water, this diazonium salt not found to be reacting. But when temperature increase in the boiling water, there the elimination of HCl, N2 nitrogen gas, and then the formation of OH group in place of diazo group. There the formation of OH group. This group can be replaced by OH. There is the formation of phenol. So firstly, the diazo group can be replaced by Cl. Say for example, chlorobenzene is there formed. This diazo group is converted into OH. There is the formation of phenol. There are two reactions. Next, when diazonium salt, benzene diazonium chloride, this benzene diazonium chloride treated with potassium iodide. Benzene diazonium chloride treated with potassium iodide. There is the elimination of KCl, potassium chloride, nitrogen gas, and there is the formation of iodobenzene. We get the iodobenzene here. Benzene diazonium chloride treated with potassium iodide, there is the elimination of potassium chloride, nitrogen gas, and the formation of iodobenzene. But when this react with hypophosphorus acid or ethanol, when this react with hypophosphorus acid or ethanol, this group is eliminated and replaced by hydrogen. So there is the formation of benzene. This reaction is very important for the conversion in many organic compound. This diazo group can be converted into hydrogen when it treated with hypophosphorus acid and ethanol or ethanol. Then this diazo group this converted into this iodine, and this when this react with phosphorus acid, hypophosphorus acid in the presence of or in ethanol, there is a formation of benzene. So we can replace this group by iodide, chloride, hydroxy, formation of phenol, replaced by hydrogen, there is a formation of benzene. Now, when diazonium salt, benzene diazonium chloride treated with CuCl, when diazonium salt treated with CuCl, there is the formation of, there is the elimination of CuCl, nitrogen, and there is the formation of benzene cyanide. This group is replaced by CN group. When this group is treated with HBF4 fluoroboric acid, there is the elimination of HCl and there is the formation of this compound 2 positive, BF4 negative. There is the formation of this compound. When diazonium salt taken with fluoroboric acid, there is the elimination of HCl and the formation of this compound. When this compound heated, it eliminates nitrogen gas, boron trifluoride, and there is the formation of fluorobenzene. There is the formation of fluorobenzene. Diazonium salt treated with fluoroboric acid, this is replaced by this compound. This compound, when on heating, there is the elimination of nitrogen, BF3, boron trifluoride, and then the formation of fluorobenzene. But when this compound react with sodium nitrate, NaNO2, this compound react with, and this process similarly, but this when this compound treated with NaNO2, there is the elimination of NaBF4. There is the elimination of NaBF4, and there is the elimination of nitrogen gas and there is formation of nitrobenzene. There is the formation of nitrobenzene. When this compound on heating, there is the elimination of nitrogen gas BF3 and there is the formation of fluorobenzene. But when this compound treated with NaNO2, this compound treated with NaNO2, there is the elimination of NaBF4, nitrogen gas, and there is the formation of nitrobenzene. Thus, this group can be converted into cyanide, iodide, chloride, hydroxide, hydrogen, fluorides, and nitrogen. So there are 1, 2, 3, 4, 5, 6, 7 chemical reaction of the diazonium salt. Now there are one reaction also that is known as coupling reaction. Important reaction for the formation of colored compound that is known as dye. This is the coupling reaction. Coupling reaction. When this diazonium salt treated with phenol, diazonium salt treated with phenol in presence of base. Diazonium salt treated with phenol, there is the elimination of HCl and there is a formation of colored dye which is known as orange dye. This is known as orange dye. What is the name? This is para-hydroxy azo, because this compound contains nitrogen bonded which attached to the 2 benzene ring. This is para-hydroxy azo benzene. This is the formation of orange compound, that is orange dye. But when this diazonium salt treated with aniline, in presence of base, diazonium salt treated with aniline, there is the elimination of HCl and there is the formation of the compounds, and which is, this is the compound. What is the name? This is also a dye. What is the name? This is para-amino azobenzene. Para-amino azobenzene, which is a yellow dye. Para-amino azobenzene, which is a color. The coupling reaction is reaction which is used for the formation of colored compound, that is known as this orange dye and this is known as yellow dye. This is all about this diazonium salt and the chemical reaction of the diazonium salt. Thank you.